In this tutorial, I'm going to cover startup for the Garmin G1000, and we'll look at the primary flight display first and the multifunction display second. However, on the actual aircraft, they will both start up and initialize simultaneously. So let's look at the PFD first, and we'll hit the power button on the top left of the bezel. Now, what I've done here is I've set failure modes for all the sensors in the simulation just so you can see how it would look with all the red X's in it when you start it up on the actual airplane. And basically what this is telling you is that the sensors are still in the process of calibrating themselves. The sensors are going to be the GPS receiver, and that's going to sit there and acquire satellites until it can get an accurate position fix. Then we have the air data sensors, which are going to measure the pressure, and so the pressure transducers are going to zero themselves so that you get accurate readings of the pitot and static values. And then we have the Attitude Heading Reference System, or AHRS. Now the AHRS is going to consist of a set of tri-axis orthogonal gyros. And the gyros measure rotation rates. They measure the rotation rates on board the aircraft along the direction through the nose, through the wing, and down the belly. And so using these three measured rotation rates, and remember a rotation rate is going to be degrees per second, we can plug those measured values into the kinematic equations of motion for a rigid body aircraft. We mathematically integrate those equations, which just means we add them up over time, and the results you get are the rotation angles of the aircraft, which will give you things like the pitch angle, the yaw angle, and the roll angle, which can then be displayed on the artificial horizon. So it's important to know that at no point in time there's no sensor on board the aircraft that measures your bank angle or your pitch angle or your yaw angle. All of these are mathematically derived from the rate at which the aircraft is pitching and rolling and banking. So when you start the system up, it's very important that you start it up when the aircraft is parked level and that nobody is rocking the wings or doing anything else that will disturb the aircraft to cause it to move. Once it has taken its necessary calculations and steps to remove the bias, these systems will become activated. And I will simulate that by turning back on all the sensors. And we can see now what the display would look like when we're ready to go and start up the engine and go flying. And we can see the synthetic vision in the background over here. So now let's look at what's going to happen when we turn on the multifunctional display. Here we can see another set of initialization routines going on, but this is not so much the sensors. What the multifunction display is initializing are databases. And we can see we have here the database for the checklist file, safe taxi, we've got obstacles, airports, chart data. So these are all the things that you're going to see on the map. And it's mostly getting these from the SD card, which you can update and then re-put into the SD slots on the front bezel. So we want to make sure we take the time to read these, know that they're up to date, that there won't be an issue that will affect the safety of flight. And once we see and accept what we have here by hitting the enter key, it takes us to the moving map and we're ready to go. So on startup, there's two things going on. There's two initialization processes that are different for both the multifunction and primary flight display. It's important that you understand what's going on, but it's nothing complicated once you understand the fundamentals. So that's all there is to it, and it's really that simple.